So in this demo lecture, we are going to cover Retrieval-Augmented Generation RAG, and due to the time limitations, we are only covering the text part. We are not going into multimodalities as we are limited on time. So firstly, let's try to understand why RAG is even required. So let's say we all have used until now ChatGPT, Claude, Gemini, and there are tons of open weight models as well, say Qwen, Llama, or even DeepSeek is open source as well, or KMK3. So if I want to build an application or a chatbot that can basically help my employees, uh, I do have a plethora of documents that have guidelines, internal documents, and policies. So that chatbot is dedicated to serve the employee's question and can respond accordingly. So in case if I use those LLMs directly, so what will happen? Since the data is not public, so those LLMs will not know and will not be able to respond. Here, consider an example of Volvo truck manufacturer that basically manufactures trucks. So, if they want to build a chatbot that can help their maintenance personnel to basically maintain Volvo trucks, there are n number of models, and each model has a manual that has over 1,000 pages. So, manually it's very difficult, and also those LLMs they do not have access to the documents. So I need to basically maintain a vector database of my own and connect my LLMs to that. So this is what RAG is, so that though that chatbot can respond according to the queries of the maintenance personnel, and that too without any hallucination, with proper citations. That's how it is intended to. So this is the real essence of RAG, and that's why it's required. So the conventional LLMs, they are static in time. They are not trained every day. Even the knowledge cutoff is, let's say, 2 to 3 years old. So they are not updated day to day basis. The reason being, training an LLM is very expensive. They also lack domain information. Let's say if I want to build an LLM, or if I want to use an LLM on legal related instructions or maybe medical related instructions, so it's possible that they are not that much domain specific. So again, RAG, the internal database, will serve as a key. And also they are black boxes, so we as individuals cannot improve them. So the only option that we have is to attach a dedicated database from which they can fetch the relevant context and then respond appropriately. And also in case if someone wants to produce them from scratch, so it's not possible since they are very costly. Let's say OpenAI, they have spent over 100 millions to train their foundation model that was done back in 2022. So it's just not possible to train a model from scratch. So when I say LLMs are stuck, so you might disagree with it, because let's say if you ask something for the recent FIFA World Cup, if you ask who won that, so ChatGPT will be able to respond. The reason being, it has search tools. So bare LLMs, they are not aware of that. Let's say if I use any of those LLM using their API, if even I use ChatGPT's any model using its API, or if I use Gemini or Claude, and I ask who won the FIFA World Cup 2026, so they will not know, because their training is not updated, and also they do not have access to search tools when used through their API. So this means that the LLMs are stuck. So uh, they can either give you hallucination or will not be able to respond. So this is what I mean when I say LLMs are stuck. So this is the conventional workflow. Whenever someone asks, let's say again the Volvo, a related question, this XC60 is the Volvo truck model. So this is the question. This will go to the LLM, let's say Gemini, and Gemini will either give hallucinated answer or will just forbid to give anything because it does not know. So again, here I am emphasizing on the fact that LLMs lack context from private data. Drawbacks of LLMs, they do not have the specifics of your business, your requirements, your customer base, internal documents. So these issues are addressed by RAG. So what RAG is, I will come to that shortly. If we do not go for RAG, so there are other three common options, but again, the RAG is the best one. So before going to RAG, we need to discuss them. The first one is to create your own foundation model. Let's say if I am working on something related to medical and I want to make my own LLM from scratch. So this is very costly. OpenAI's initial training costed over 100 million. So this is just not the right way to go forward. So we just cannot create our foundation model from scratch. And even if someone has that amount of funding, so still the data is scarce. Data preparation is also very tedious task, and uh, this will again incur both time and cost. So this is just not a viable option. The second option, which is a little more viable, is fine tuning. So firstly, we need to understand what fine tuning is. Fine tuning is retraining a foundation model. Let's say if I take the models, the weights of llama, and I fine tune it on my own downstream tasks. Let's say medical related question answering. So this is what fine tuning is. It is in comparison cheaper, but still there are some challenges because you do still require expertise. Not everyone can do fine tuning. You need to have AI engineers, machine learning engineers who can do this, and also then you need to run them on your own servers. So you need to manage them as well. And also, this is another edge case that you need to consider. Let's say I fine tuned the base model on my entire business data, and after fine tuning, I just sold my car. So since I cannot do the fine tuning on daily basis or on recurrent basis because it's cost incurring, so the LLM will not be able to know what happened. So recency will still be a problem even if I find. The third option, which is the most basic one, is prompt engineering. So you will say you can think of, let's say if you have 1,000 documents, so why just you cannot pass all of them as a part of the prompt. The reason being the LLMs have limited context window, so you just cannot throw everything to it. The context window will be overflown, and you will not be able to. You will in fact get error, and you will not be able to get the answer. So that's why prompt engineering can help in brief scenarios, but in case if we have an entire corpus, let's say Volvo, there are too many manuals. So in that scenario, prompt engineering is not sufficient. Then the only option left is RAG. So what RAG is? Uh, this is the upload or the ingestion part of RAG, where we have an embedding model. Let's say we have some documents, Volvo documents, and we have an embedding model. Consider right now sentence transformer, which is the most common open weight model. So that will basically consider documents into embeddings, and those embeddings will be stored in the vector database. So what embedding is? Embedding is again a transformer model that converts into the data into vectors, and those vectors are then stored into vector database. In this example, we will focus on Pinecone, but keep in mind that Pinecone is not the only vector database available. There are many others as well. But just that in this code example, we will be using Pinecone, so I will repeatedly use the name Pinecone whenever I talk about vector database. The upside of it is that we can create vectors on the fly. Let's say if I just sold my car, so I can just ingest the updated document and the LLM will have access to it. So this will also remove the recency problem. When it comes to the most common embedding model, sentence transformer is one of the most common open weight embedding model. There are many other as well. Let's say I worked on medical related Brack. So in that scenario, I used embedding model that was specific to medical related corpuses. For legal related corpus, I used legal word, which was very good in that scenario for encoding and embedding the legal data. Now let's discuss about vector database. So they are just like any other database, the SQL database or no SQL database. They basically store the information and keep your application stateless. So this is its purpose, but the storing mechanism is different. It does not have tables, rather it has vectors and their metadata. So the embedding model is converting the text into embeddings. So those embeddings along with their metadata is stored in the vector databases. There are two common types on a high level. The first one is in memory, let's say files, and the second one is external, which is fine. And then semantic search is another keyword that you will come across. So let's say if I embedded the entire company document and stored it into the vector database, now user comes in and does a query. Let's say Volvo 600 pump oil pump replacement. So that query will also be converted into embeddings, and then there will be a semantic search between the embedding of the query and whatever the embeddings of the corpus that we have, and the best matches will be served, and they will again go to the LLM. This process I will explain thoroughly once I will come into onto this diagram. So this diagram basically explains the RAG. The basic RAG is totally this diagram. So this is the upload pipeline. This one, if you can see my cursor, this is the upload pipeline. This will only trigger once we have new data, else we will not trigger it. Generally, we only trigger it in the initial, and then maybe monthly basis or fortnightly basis or maybe quarterly basis. So it's generally not run on daily basis, but there is no harm even if we want to run it on daily basis. So let's say Volvo has too many maintenance manuals, and they basically show all of them to the embedding model. The embedding model converts those documents into embeddings and stored into the vector database, which in this case is fine code. Now this process is completed. Users comes in and does a query. Let's say uh, truck V600 oil pump replacement. So that query is again converted into embedding. These two embedding models should be the same. Let's say transformer, sentence transformer V6. So they should be the same. Else the embedding, if the embedding models are different, so the semantic search will not be able to work. And then this embedding will go into the vector database alongside the query. And here the semantic search will occur. And this will basically fetch the most relevant context from within the vector database based on the query embedding. And then this context alongside the original query will be passed onto the generative model or the LLM, which could be anyone, let's say OpenAI's model or maybe GPT-5, Gemini 3.1, or Claude Hiku, or whatever open weight model, let's say Kimi K3 or maybe Cuban or Llama, whatever. So if this part is done correctly, so the generative model generally they works well. So this is the entire generation pipeline. This one. So I have highlighted that. So someone searches something and gives a question. That question goes into the embedding model, and then that embedding goes into the vector database and retrieves all the relevant context from that, and that context alongside the original question goes into the generative model, and you then get a reliable answer. So this is what RAG entirely is. Breed anchor basically adds to the efficiency of the brag. Let's say in some scenarios, this is an example where let's say you have n chunks retrieved. The best chunk was here, second last n minus one, and you then thought that there are a lot of chunks and I want to reduce the number of chunks because this can essentially basically overflow the context window. So I thought that only four chunks should be going into my LLM. So doing so, this one is stopped because this one is occurring on the one, two, three, four, five, six, six. The original answer was on six, and I basically shortlisted that only the first four should be going into by generative part. So doing so, if I am not re-ranking, so what will happen is that I can basically drop the essential information. For that, we can add another interim step for the re-ranking, and that can basically re-rank it. And doing so, you can see all the relevant answers are basically re-ranked by an interim LLM, and then the generative part will have them and will be able to basically respond. So this is conventional process where user queries something, goes into the embedding model, and then vector database returns the context, and that context will directly go into the generative part. Here we have added a re-ranker. So this retrieve context goes to the re-ranker, and you can see the blue one is on the top. So it basically re-ranks. So let's say if we had 10 chunks retrieved and we only want to keep four relevant ones. So that's totally possible. The re-ranker will firstly re-rank and then you can just drop the chunks from 5th till 10th. So this will also save you tokens as well, and also this will reduce hallucination because the less the context, the better will be the less the context windows occupied, the better will be the responses, and the less will be the LLM hallucinate. So this is what the edge case of re-ranker is. Here you can also see the best answer. The this one is on fourth, and we decided that we only keep three. So if we do so without adding any LLM, so we will definitely miss the original answer. So re-ranker basically firstly re-rank it, and then you can only consider a top three. So this is how re-ranker is adding significance to it. It will again add some latency, but not at the cost of accuracy.